Let's continue with our code for the JiraLib. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Now, if you recall, in previous video, we finally merged our block properties into one class, and that causes lots of errors inside our G block. Now, in this video, I will try to fix the G block, and then in the next video, we will take a look at these 6 different classes that we have for the block entity, and I will try to reduce it to 2. Honestly, I could go with 1, but that is not the correct way of doing it. However, we will talk about it in the next video. So to begin with, the very first thing that we know is that now block properties is accepting a T extends block entity. So here we don't want to bind the G block to a block entity using generics. Instead, we can use a wildcard that says block properties of any generic type. And take note, if I just use the markers for the generic, it will not work. I need to send in the wildcard there. The question mark, for those who don't know generics, means that anything, okay, any type. For the state properties, we change the name, and that is get state properties, and most of these should be the name changes. For example, again, we have the get state properties here, and let's see, here we have get state properties. Now here is the thing, if this dot properties facing opposite, this is not the case anymore. So let's take a look at facing opposite. Is facing opposite, that's what we want. I had paused the video and forgot to start the recording and done everything in the class. Holy crap. And I'm not going to roll back, but I will talk you through it. Normally, whenever we were using something with the block entity, we were checking if the block entity is null or not. But this time we don't need to do that. Other than is facing opposite and get the state, the different things that we start working on is related to block entities. So here you see that in the create block entity, we want to make sure that we have a block entity and we have a factory. Before, we had to check if the BE properties wouldn't be null, but here we don't need it. All we care is that we want to make sure if the get BE factory doesn't return null, because the get BE factory will directly returns the block entity factory. And you see that whenever one of these two conditions are null, the block entity factory will be null. So we are checking if it's not null, it means that we already had assigned a type for the block entity, so we can instantiate and create it. Then for the ticker, again, we don't need to check the properties to be null or not, but we want to make sure that the BE type is not null. Now BE type returns this block entity type supplier, okay? But it is returning .get on top of it. When we are assigning the type supplier here, we want to make sure that we have something. Now, this is a little bit of a problematic code right now, because if this has a supplier that returns null, okay, the get result will be null. But if the block entity type supplier is null itself, then we will have a problem, and we are not checking it here. So I need to add it. So if this.block entity type supplier equals to null, actually I will say, or the get equals to null, I'm not true, I will return null. And this is a better code now. Of course, I need to push to the Maven and re-update myself, but this is a minor thing to do these days for me. When we get here, the get BE type shouldn't be null if we introduce a block entity. Now we can say this properties is tickable. Again, is tickable will be set properly, because when we are setting the tick method, we are checking if we are null or not. If we are null, we will throw an exception. So if we get here, means that if it returns true, we already bypassed that exception. So we have provided a type for the block entity. The rest is just method name change. Now for the ticker, this is the vanilla way of doing things. I don't care about that right now because we didn't have anything to do with that. This has been changed in name to get comparator output here. And actually, wherever you see something like render type, for example, here down below, if I find it, here we go. It's again changed to get render type. Shape factory here was renamed to get shape factory. And here we only need to check if we have the GUI, because again, we are checking that null point and throwing an exception. So if has GUI returns true, means that we already bypassed that exception, and the rest is just the code we had. So this looks like it's complete. However, we have a little bit of a problem here, and I have talked about about this in the main video tutorial series, and you will see that video actually before you see this video, because the main series is ahead of the upload of the library videos. However, remember that I recorded that main video tutorial series after I work on this video right now. So the problem is that in the main series I showed you that things has changed in 1.21.5. Basically, before 1.21.5, on-state replace on the block was responsible of the breaking of the block and handling the state change there. However, these days we have two different ways of handling it. One of them is just calling the onBreak. Let me go directly into the block class, and I think I can't do it here because this is not being added to, as I guess. When I'm inside gblock, I shouldn't be able to do that, but here maybe abstract block and from net Minecraft. Okay, so if you take a look at the structure here and we are sorting it alphabetically, we have a method that is called onBlockBreakStart, and then if you look carefully, maybe here, maybe on the block class itself, we have onBreak. Okay, so these two methods is called exactly when the block is being broken, before the state change. Means that you just finished breaking the block, but it's not still replaced with air. At that moment, we have that onBreak. So if I want to, I can call here onBreak, and you see that it's returning a block state, and I can use part of this code or do whatever I want to fix the breaking state of the block and drop the content if it has an inventory. However, this has a little bit of problem. The problem is that this method will only called when we are breaking the block by a player. So if we have a block entity in the board that will call word.breakBlock, or I don't know, set the state to air, like what we have done with goo, or anything else actually, this method will not be called. Even if a TNT explosion causes the block break, the onBreak will not be called. So how should we handle dropping the contents of a block in the board in case that the block has an inventory? We have another method in block entities for that. So if I open any one of these block entity classes and track it down to the block entity class, let's do it this way. If I can find the, for example, abstract furnace block, and I open it, you see that on-state replace these days in 1.21.5 is only calling this, and it's only calling that on every one of the blocks that are sitting in Minecraft. On-state replaced on the item scatterer, this only do one thing, and that one thing is to call update comparators, nothing else. So instead of on-state replace on the item scatterer, you can just do this, and I will copy it, actually coming back to gblock, and I will remove this part, I will uncomment this, and all I will do is just call that, and if we take a look at this, it's called state, and that's the first param. I think I changed it. Yeah, I changed this name myself, so it will be state, and that's it. Nothing else will sit on the on-state replace. If you want to be cautious and careful, just in case that Minecraft team adds something else here, you can just get that item scatter code and put it there. And that's it. Honestly, that is it. So the rest will happen inside our block entities. Now, I was going to work on the block entities in another video, but I thought to myself that, you know what? This video is not long, so why not move into the pitfall of block entity and try to figure out what we are doing and what we are not doing, because I'm telling you, we have some problems here, and I did miss that problem. Okay, let's start by the base, updatable BE. Now, updatable BE is a block entity that implements iUpdatable. All it's doing is adding the update method and on tick end method. Of course, we have the sync code, and yes, we can register default fields if we want to, but one thing that you may find is that we are not calling it inside our constructs. So right from the start, that's one problem. This method is not being called in here. Now, I don't remember if I did call it inside the block properties or not. Let's copy it. Let's go into the BE properties, put Ctrl F and search. No, we didn't use it here. Let's go into block properties, Ctrl F, search. We are not using it here. So this method is not being called anywhere right now. That's one problem. Also, the other problem that I completely forgot is that here we are checking if we should wait for the end of the tick method, then we mark ourselves dirty. And here we say wait end tick to false. If I'm using the updatable BE right now, each time I call update, I will mark dirty. I will immediately update the listeners. So I'm not waiting for the end of the tick. I'm just constantly updating the listeners around myself. And maybe this is not what we want to do. So how can we solve this problem? Question is, when do we want to wait for the end tick? The answer is when we have an inventory of some kind or a storage container of energy, fluid, or any other storage container of some kind. At that time, we want to wait for the end of the tick before syncing the data between client and server. And we thought that we are handling it inside synced BE. Let's see. The constructor is not what you think it will be. Because if you recall, we have the properties. And because I called super on the synced BE, I thought that, okay, we are doing everything we need with the properties. However, I totally forgot that here we are setting the wait and tick to be false. And even when I'm calling the sync, I'm not waiting for the end tick. And again, we have the same problem here because we are not doing anything with update. And even more confusing, I have this sync, then I have a method for get syncables. Let's take a look at the isync tick because things become much more interesting when we dive in here. So isync tick, of course, is iTick and isync. iTick is okay, but the isync has a sync method and get syncables method. That makes sense, but take a look at here. Then we have a should sync here, and you may ask yourself, what is the responsibility of this sync method? Because if we go back into the method calls, we don't see any functionality added here other than just register the default fields. That's okay, but then we are not calling that sync here. Let's take a look at isync. Isync is overriding the tick. Okay, here, if you take a look, we check if the block entity should sync. If that's okay, then we are getting the syncables list. If it's not null and it's not empty, then we move through each one of the items in this list and we call the sync method on them. Wait a minute. If the sync method is related to something inside the block entity, then why should I have the sync method as a parameter of the block entity? That doesn't make sense. Well, the reason is that I was trying to combine two things at the same time. Honestly, isync is for the block entity itself, but I need to have another interface and I will call it iSyncable. And of course, it's interface iSyncable will have this void sync. So I will remove it from there and I will put it here. And guess what? Now we need a list of iSyncables, and if I'm going back here, I'll get a list of iSyncables and I will call the sync method on the iSyncables. So anything that I have in the inventory that needs to be synced, I need that thing to implement the iSyncable. So now we are dissecting the syncing mechanic in the BE from anything that needs to be synced that sits inside the block entity. For example, if we have an inventory, the inventory should sync itself. However, the block entity shouldn't call the sync method. The block entity should take a list of inventories that it has and go and take each inventory and tell the inventory that, you know what, you need to call the sync on yourself. And that's it. We didn't add the updatable as an implemented section of any of the interfaces, okay? We have the isync tick, but this is not calling the update. Update is totally an isolated content. Now, let's see if we can make things work in a better context. So for the block entity, I will need to add a new class calling it GBE or I don't know, GBlock entity. And this guy, like the updatable. Now, do I want to start with the updatable or we are extending the block entity? So let's start from here. We are extending the block entity and then we are implementing the updatable. So far, so good. However, you notice that I have this generic here and I need it as we established in the previous videos because, well, we need to have the properties being bound to a type. This is not updatable. This is the gblock entity. We implement the methods update untick end and we don't need the these client ones, so just add them and then create constructor. Now, instead of any type, we want the type of T, as you see here, and I need these three. I will move them on top. And yes, I'm removing things from updatable because I want to make sure that I'm cleaning this thing. So after calling the super here, well, I'm not gonna touch anything on the properties maybe. So I will just get this section and then I will call the tick rate on it. Actually, you know what? I think I will take the properties from the constructor. So we get a type, we get a position, we get a state, just like so. And this is saying unchecked cast G block entity T to T. And it's updatable BET extends updatable BET and block entity type of T, B properties of type T. So here, G block entity T extends G block entity T, B properties of T. That's exactly the same thing. I don't see why these two have a conflict with each other, other than being abstract, of course. So let's remove that abstract part. Updatable. We are doing the same thing here. Yeah. So why are you yelling at me about that? We are suppressing the warning unchecked. Okay. So let's do the suppress for that. Now that we have the properties, as you see, I will not add any one of these. And I will show you why in a mockup example later. However, right now we want to have these. So after calling the properties, we are adding things to the properties for the isDirty and isDirty client. Then we have the update. Now update doesn't return Boolean anymore. We did change that. We get this part, and from there to there, we mark it to be dirty, and should wait and tick is changed its name. Dot, what do we have? Dot is waiting and tick, and we call it mark dirty, update the listeners. Then the on and tick is the same thing as before. And of course, we want to have these at the end. However, I didn't add this method call. Now I will add that method call right at the end of the constructor before I forget. So far, so good. Now let's move one level above. The tickable, it needs iTick, but I prefer to use iSyncTick directly here. So I will go with iSyncTick. And yes, now it says that I need to override more methods for onTick. onTick client should sync and sync. Now, I don't want sync. Okay, I know what's going on. This one should be removed because guess what? We have changed the base, but I didn't push the Maven. Okay, let's get this one to the second section down and let's compare these, because if you noticed, both of them are going from updatable BE. And I'm repeating myself here, the tick client, and then constructor, this.tick, this.client tick. The things that are changing is that in the iTick, I'm overriding the tick method, but iSyncTick had already used the tick method in the interface. So we don't need to override it anymore. So I don't need that part. Then we have the tick client. Of course, it's the same deal here, I think. So that's the same code there. This is the same code there. This is the same code. So let's move down. Registered default fields. We are adding the stuff like the word, the position, the cache, the state, ticks, client ticks. Again, they are the same. Then we get the ticks that returns ticks. Of course, as I said, the sync will be gone. We have a should sync that we will override. So this is the same again. Client ticks. This is the same again. Then on internal first tick, we just call register default fields. Oh, we call it on the internal first tick. I see now. Yeah, that makes sense. You know why? Because in the constructor, we may not have all the information that we want to add. Well, we will definitely have the word, we will definitely have the position, the cache, the state, or these two values actually at the end of the constructor. But this time, I would say that ticks and client ticks may not, because here we will not assign the values to them. We will let it be set by the classes that inherit from this guy, okay? So we need to assign those values not in the constructor at the end, because at that time they will be 0. Of course, we can add the property here to the fields. I'm debating. Oh well, we will see what will happen. So on internal first tick client, it says just on first tick client. On first tick is empty because that's what we will do ourselves in each class. Same goes here. On internal tick, we are checking the tick logic. And for the client, we are doing the same thing. And finally, we have this register fields that we can add. Guess what? The iTick BE is completely deleted. that was a duplication of iSynced tick. The only difference would be the tick method content. Now, because we are implementing iSynced tick, we don't need to handle the tick method ourselves. So we will continue from here. I will move it to the second monitor, and from top, I need the ticks and client ticks, and I need to add 2 more of these. This is why I said that I will stop and wait for, actually, you know what? I will get these. Do I want to have them in the constructor, or I can put them here? Because these are actually the default fields, part of the default fields. So I will cut them, remove them from there, and I will add content here. So this one will be not isDirty, but ticks, and this one will be ticks client. So we use this.ticks, and this one is client ticks. Of course, the name needs to be changed later, but here again we go with ticks, and the value is integer. So why are you yelling at me? Package private? No. Okay, client ticks. We will see what is the problem in few seconds, and that's that. Again, it's yelling at me. So let's go up and take a look, because these are private. They should be protected. Okay, so now that we have that, we want to have the other stuff. For these, I can go with something else. Instead of going this way into the getter and setter methods, I want to do something else. Now let me see. Do I want to keep these as protected, or do I want to put them as private? Now, if I make them private, I need to have the get and set methods for them. If I keep them as protected, I can handle the values inside the block entities without the need to call an override or anything like that at any time. And the only difference is here. Actually, I will keep them as protected, and I will keep them the same way without the need to change them. Then we have the other fields, and I will copy them from here and I will paste them. So we have the word, and it's not sync be get word, because we are just G block entity, and this is the get pause and get cache the state. As you see, we don't have any setters for these. So that's our registered default fields. Now I will remove that from my notes, and let's start from top. On tick, here we say if, actually let me get it from the code, and we will take a look at the whole thing. So if ticks equals to 0, this dot on internal first tick, of course we don't have it yet, then this dot properties dot tick rate equals to 0. Get tick rate is the new name, and here then we go with on internal tick. We have the same thing for the client, so I will just cut it, I will paste it here, and again these two are get tick rates. Then we have should sync. Should sync will return this dot properties dot is syncable. Now again, a little bit of name change. We don't have this sync method. Now this is protected for the ticks and tick clients, but let me have their own get methods. So I will say get, we say public int get ticks, return this dot ticks. Then I hope it's smart enough. Yes, for the tick clients. Do we need to find the isDirty or isDirty client? No, those two will be used internally. So after these, we will call the private void on internal first tick. Here we say register default fields. So this will call this method. Then register fields, that it will be our custom fields, and on first tick. Then we have another one, private void on internal first tick client, that we call on first tick client. We have private void on internal tick. Yes, we get the tick logic, but let me see. It returns the tick logic like this. So we don't have that get name in front anymore. And again, on internal tick client, tick logic, tick client. Finally, we have our protected void on first tick, protected void on first tick client, and register fields. So we already have what we need inside the block entity, and this is the complete method that combines 3 different ones: the updatable, so I removed that, tickable, and synced. We have fixed these 3. Are we finished? I will say no. One of the things that we need to fix is the method call from iSynced that I'm not sure why it's not showing up, or maybe I missed it, but it should be get syncables, and I don't see it here. Maybe because we have it written here. Yes, get syncables is returning an empty list, and I'm not gonna override it because, well, guess what? We will return an empty list again. I will make this class abstract, and because it's now abstract, I will remove this sync method. We will not have any errors, but guess what? When I recover the Maven repositories and refresh the sync gradles on everything, then we will not have any sync method there. Now, this is one of the two classes that I want to write. If I go back and I look at screen synced BE, you see that it's an extension of sync BE that implements IBE screen. And this is exactly what we need. So I will say a new class that is G screen BE for BlockEntity this time. And of course, we need this section now, but instead of this screen sync BE, it will be G screen BE and extends the G block entity. Now, do we need to send in iSync and anything else? No, we just need to implement the IBE screen because we are handling the rest here. And all we want is this get screen opening data. So if we go here, it says implement methods. Well, sync is okay, get a screen, get display name, and create menu. Now, other than that, we just need the constructor. Guess what? I will make it abstract. And now we won't have this sync method at all to bother with. We won't send the display name or this create menu. We can't handle them here, but we can get this screen opening data, and it's an abstract again. So guess what? I will remove that one too. And this is our G screen BE. All we had done is implementing this interface. Okay, I will not add it on top of this class because you know what? We have Goo blocks, for example. They don't have any user interface. So why should I bother with that? And honestly, I don't know why in the first time I did bother myself with this abstraction, because if I'm calling this abstract, I can remove this one. It would work without any problem. However, now that we have it, well, we can simply say that we are done with everything, close that, and again, we don't need these, and I will remove screen synced BE, tickable, and updatable. So now I have ended up with two different classes, one for any block entity that doesn't have user interface and one for a block entity that has a user interface. Now in the next video, I will come back and I will add something that is not used all the time, but it's nice to have it. And I will talk about items that has screen handlers, and you may want to handle tick methods inside those screen handlers. For example, a practical example can be a portable charging item. So you have an item that uses energy, you have another item that saves the energy inside of itself, and it's portable. Now you want to put the tool inside this portable and get it charged. Now guess what? Right now you can, because the item that is portable energy container is not tickable. It's not a block entity, it's an item. And normally items wouldn't tick, and your only way of handling tick methods on them is to just finding the tick inventory event and add some logic on top of it. This is a bad practice. I will talk about these in the next video. So in the next video, I will come back and I will add something here, especially in the client section, and we will see how it will work for any screen handler that should tick itself without being related to a tick method on a block entity. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.